This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at triple integrals and applications. And let's take a look at our first problem. Zero to 2. Sometimes I find it beneficial. See how that's on the outer, and then over here the outer is z. So sometimes I find it beneficial to put the variable in there. Then I can easily keep track of what's what. Next one will be a y. So y is equal 0 to 3. A lot of books don't do this. Then x equals 0 to x equals 1. 2x minus y plus z dx, dy, and dz. Well, I'll work with the inner integral first, this one. So this carries down, so we got z is equal to 0 to z is equal to 2. Y is equal to 0 to y is equal to 3. Now I'm integrating this with respect to x. So the 2x, the 2 remains, and add 1 to our power, divide by new power. The minus y, that we treat the y as a constant, and if we're integrating with respect to x, so this will be a minus xy plus xz dy dz. Oops. Try it again. This is from x equals 0 to x equals 1. Okay, so we got z is equal to 0 to z is equal to 2, and then this carries down also. Y is equal to 0, y is equal to 3. I can simplify this a little bit. Those 2's cancel. We got x squared minus xy plus xz. From x equals 0 to x equals 1. Well, now we'll plug in those numbers. So I got z is equal to 0, z is equal to 2, y is equal to 0, y is equal to 3. We'll put 1 in for x, so we're going to have 1 squared minus 1 times y plus 1 times z minus, and then I'll put parentheses, has changed the sign of everything that follows it. We'll put 0 in for x. So I got 0 squared minus 0 times y plus 0 times z dy dz. Well, the 0 squared drops away, 0 times y drops away, 0 times z drops away, so all that drops away. And I got 0 is equal to 0 to 2, and then 0 to 3. Okay, 1 squared is 1 minus y plus z dy dz. So now we want to integrate, again working with the inner one first. We want to integrate with respect to y. Anything with a y you treat just like normal. Everything else that doesn't have a y you treat as a constant. Well, 1 becomes y minus, and this y here is 1/2 y squared plus, and again we're treating the z like a constant, so this will be yz. From y is equal to 0 to y is equal to 3. And I wrote that down incorrect. Let me try that again. Those should be dz's there. I's are crossing. Well, now we can plug in the numbers. So plug 3 in for y. So we're going to have 3 minus 1/2 times 3 squared plus 3 times z minus, and then we'll plug 0 in for y. So we got 0 minus 1/2, 0 squared plus 0 times z, which gives us This 0 drops away, 0 squared times 1/2 drops away, 0 times z drops away, so we're left this first part. So we've got 3 minus 3 squared is 9 times 1/2 gives us 9/2 plus 3z dz. Let's simplify that a little bit more before we do our last one. This is a mixed number. You take 3 times 2 is 6, plus a negative 9 gives us negative 3/2 plus 3z dz. Okay. Well, whenever you have a number, you just put the variable on it, so it becomes negative 3/2 z plus 3/2 z squared. Add 1 to our power, divide by our new power. Now we're ready to plug in our numbers. So plug in 2 for z. So I got negative 3/2 times 2 plus 3/2 times 2 squared minus, I'll put parentheses, that's affect the sign of everything follows it. And now plug 0 in for z. So I got negative 3/2 times 0 plus 3/2 times 0 squared. Well, these 2's cancel and we've got negative 3 plus 2 squared is 4 times 3 is 12 divided by 2 is 6. Negative 3 plus 6 is 3. Assuming I didn't make any basic math error anywhere. So let's go ahead and save that. This is triple integrals and applications. Triple integrals and applications. Page 01.pdf. There we go. And let's look at our second problem. The outer one is a z, so z is equal to 0, from 0 to z is equal to 1. Next one is x. So this will be x is equal to 0, x is equal to 2. And next one is y. So this will be y is equal to 0 to y is equal to x. Of z e to the x squared dy, dx, and dz. By putting these letters here, these variables, it really does help keep everything clear. You know exactly what you're working with. So let's work with our inner one. That last problem where I flipped the dz to dx by accident, I wouldn't have noticed that if I hadn't had these variables here. So it's kind of a double check to make sure you don't screw up. And in real life, outside of education, the key is not to make mistakes that'll cost you a company $1 million. So, well, we're going to integrate this with respect to y. There is no y's, so all we do is put a y on there. So we've got yz e to the x squared. Again, we treat those like constants; they just remain. And then it'd be like taking the integral of 5. It'd be 5y, so this is just that y. And this goes from y is equal to 0 to y is equal to x, dx, dz. Well, now we're ready to plug those in. Now realize that the only thing we're plugging these in for is y. So I could take the z e to the x squared and put it out in front. So I'll put a z e to the x squared out in front of the bracket. And then we're plugging these in for y. So I'll put the x in for y, minus, put 0 in for the y. dx, dz. So we've got z is equal to 0 to z is equal to 1. And the z here would be the constant portion. So we could, if we wanted to, even put it out in front of this. You can't put it clear out in front, but put it out in front of this integration. X equals 0 to x equals 2. And then I got x e to the x squared dx dz. This is a u substitution. We'll let u equal to the power on e, so u is equal to x squared. Du would be 2x dx. Well, we have the x, we have the dx, but we don't have the 2. And we can put the 2 in there. We have to offset it with the 1/2. And I'll put the 1/2 clear out in front so we don't have to worry about it. And then x equals 0 to x equals 2. And this is 2x e to the x squared dx dz. Well, now we can do our substitution. So I got 1/2. Z is equal to 0 to z is equal to 1. And I'll keep my x values here. Some people like to switch those to u's. And this becomes e to the u du dz. And again, we're doing our inner one here, so working with that. So we'll have 1/2. Z is equal to 0 to z is equal to 1. Z, the integral of e to the u is e to the u from x equals 0 to x is equal to 2. Now this is a common mistake I'll make, is I'll try to plug these in for the variable. But if I have my x equals here, I know this is u, so I see they don't match. So again, that helps in so many ways to have that there. Well, we plug our u equals back in. If I scroll up, we said u is equal to x squared. So we'll put that back in. We got e to the x squared from x equals 0 to x equals 2 dz. Now we're ready to plug in those numbers. So we got 1/2. And we'll plug in the 2 for x. So we got e to the 2 to the second power minus e, and we'll plug 0 in for the x. So we got 0 to the second power dz. Okay, so now we got z is equal to 0, z is equal to 1, z. Now 2 squared is 4, so this is e to the 4 minus 0 squared is 0, e to the 0 is 1. Anything to the 0 power is 1 dz. Now that e to the 4th minus 1, that's a number. So we can put it clear out in front. So we've got 1/2 e to the 4th minus 1 from z is equal to 0 to z is equal to 1 of z dz. So this carries down. The integral of z is 1/2 z squared from z is equal to 0 to z is equal to 1. The 1/2 I can put clear out in front. So we've got 1/2 times 1/2 e to the 4th minus 1. And we got z squared left in the bracket. We'll plug 1 in for z squared. So we got 1 squared minus, and we'll plug 0 in for z. So we got 0 squared. Well, 0 squared drops away. 1 squared is 1. 1 times anything doesn't change. So it all drops away. And we got 1/4 times e to the 4th minus 1. And assuming my eyes didn't cross and I switched something or so forth, that would be our answer. So let me go ahead and save that. And let me grab a drink here. Our volume, if f is continuous over a bounded solid region Q, then the volume of the solid region Q is given by this formula, where you got a triple integral, and Q is going to be in terms of x, y's, and z's. Okay, let's look at our next problem. Okay, it says set up a triple integral for the volume of the solid. Hint, plug zeros in for the variables that are gone, solve for the current variable. Okay, so we got z is equal to 2 minus x minus y. And let's go ahead and do our setup. There's probably enough room there. And then we'll have our dz, dy, and dx. Solve it in the first octant. First octant implies that everything's positive, and it starts at x equals 0, y equals 0, z equals 0. So for this one here, this is going to go from z is equal to 0 up to this right here. Z is equal to 2 minus x minus y. Oops. So z is equal to 2 minus x minus y. Now our next one is going to go from y is equal to 0. And at this point, to find the y's, we have this. We plug 0 in for z. So we got 2 minus x minus y. And then we want to solve for y. So we take negative y over, and we get y is equal to 2 minus x. So this is going to be y is equal to 2 minus x. Now for our x's. Again, they all go back to this. Z is equal to 2 minus x minus y. Well, z is still 0. That was 0 here. Now y is 0. So as you go back, each one of these, you just plug 0 into the variable that was before it. So then you take negative x over the left side, and we get x is equal to 2. So this is going to go from x equals 0 to x equals 2. Okay. And that gives us our volume. So work with the inner integral first. Okay. This is like an invisible 1 here. So we integrate in respect to z, then it just becomes z. 1z or z. And we're going from z is equal to 0 to z is equal to 2 minus x minus y. dy dx. Now we'll plug those values in. So x equals 0 to x equals 2. Y is equal to 0. Y is equal to 2 minus x. We'll first plug in 2 minus x minus y for z. So we got 2 minus x minus y minus, and then we'll put 0 in for z. dy dx. And then, okay, the 0 drops away, and now we're integrating respect to y. So the 2 is a constant, so it just becomes 2y. Actually, what am I doing? I was going to simplify it first. Okay, 2 minus x minus y. 0 just drops away. Didn't get to go to the y this morning, so I'm kind of out of it. Okay, again, we're doing the inner integral. So integrating that with respect to y, the 2 is just a constant, so it becomes 2y, minus, and we're integrating with respect to y, and the x would just be considered our constant portion, so that'd be minus xy. Again, if you have a constant, just put a y with it. And then a minus 1/2 y squared. Again, this has a y in it, so we add 1 to our power divided by new power. And that'll go from y is equal to 0 to y is equal to 2 minus x dx. Now we're plugging those values. So for the y, we're going to plug in 2 minus x. So we got 2 times 2 minus x minus x times 2 minus x minus 1/2 and then 2 minus x squared. Minus. Now I'm going to save a little bit of room here. If I put 0 in for y, 0 here, 0 here, 0 here, all that's going to drop away. So all that goes to 0. Okay, so x equals 0 to x equals 2. 2 times 2 is 4. 2 times negative x is negative 2x. Negative x times 2 is negative 2x. Negative x times negative x is positive x squared. Minus 1/2. 2 minus x to the second power gives us 4 minus 4x plus x squared dx. Let me double check that. Okay, so we got x equals 0 to x equals 2. 4 negative 2x is negative 4x plus x squared. Take the negative 1/2, multiply it through. Negative 1/2 times 4 is negative 2. Negative 1/2 times a negative 4, negative times negative is positive. 1/2 times 4 is 2, so that becomes 2x. Negative 1/2 times x squared is negative 1/2 x squared. And from x equals 0 to x equals 2. Combine together the x squareds. Here I got x squared minus 1/2 x squared. That gives me 1/2 x squared. Negative 4x plus 2x is negative 2x. So that's gone, that's gone, that's gone, that's gone. 4 minus 2 gives us 2 dx. Okay. Now take the integral of that, add 1 to your power, divide by your new power. So I've got 1/2 times 1/3 x to the third minus 2 times 1/2 x squared plus 2x from x equals 0 to x equals 2. Which gives us 1/2 times 1/3 is 1/6 x to the third minus 1/2 times 2 cancels, so that gives us x squared plus 2x from x equals 0 to x equals 2. So we'll plug these in now. So we got 1/6 times 2 to the third minus 2 squared plus 2 times 2 minus, put 0 in for x. So we got 1/6 times 0 to the third minus 0 squared plus 2 times 0. Well, all of this back part drops away because it equals 0. 2 to the third is 8 times 1/6 is 8/6 minus 4 plus 4. And those 4's cancel, and this reduces to 4/3. Assuming no basic math / algebra or / basic calculus mistake above. So let me go ahead and save this. I could work off of a script. I mean, I definitely work them ahead of time just to make sure I remember how to work them. But I don't have those in front of me because then that'd be kind of boring. And then I wouldn't do it. Okay, let's look at our next one. Set up a triple integral for the volume of the solid. Doesn't look like they want us to actually go through and... last one was just to set it up too. I should read my instructions. Okay. Maybe a script wouldn't be a bad idea. 4 minus x squared minus y squared. And z is equal to 0. So set up a triple integral for the volume, and then I guess set it up and you're done. Okay. Now let's first start with z is equal to 0. Well, then it goes up to this one. So z is equal to 4 minus x squared minus y squared. Pretty straightforward. And then this would be dz. Now our next one, our y's. Okay, we're starting with our equation. Z is equal to 4 minus x squared minus y squared. The variable we just did was z, so we put 0 in for z. So we've got 4 minus x squared minus y squared. Take the negative y squared over, it becomes a positive y squared. Square root property. Drop your squared, put a plus or minus square root around the other side. So then this, y is going to go from negative square root of 4 minus x squared to y is equal to positive square root of 4 minus x squared. Now for our x's. We got z is equal to 4 minus x squared minus y squared. We already said the very first one we got rid of was a z, so we'll put a 0 in for z. The one we just worked on was a y, so we put a 0 in for the y. So those go away. We can take negative x squared to the left side, and we get x squared is equal to 4. Drop the squared, put a plus or minus square root on the other side, and we get x is equal to plus or minus 2. So this is going to go from x equals negative 2 to x is equal to positive 2. And this would be dy dx. And that's our answer. And I'll try to read the instructions a little bit closer next time that says just do the setup. So let me go ahead and save that. Not that it hurt me to work that problem. But okay, let's look at our next problem. I'll grab a drink first. This one says use a triple integral to find a volume. So I guess they want us to go through and solve this one, not just do the setup. Okay, so bounded by z is equal to 9 minus x squared. Y is equal to 9 minus x squared. First octant. First octant, everything's positive, and it starts at x equals 0, y equals 0, and z is equal to 0. So that's going to help us in our setup. Okay, so we got this right here, and we're going to start off at z is equal to 0, because remember what I said, they all start at 0. And then it's going to go up to z is equal to 9 minus x squared. Now for our y's, that's going to go from y is equal to 0 to y is equal to 9 minus x squared. It says right here, doesn't it? It says y is equal to 9 minus x squared. Now let's look at our x's. Okay, so we're starting with y is equal to 9 minus x squared. I started with this one because this would be the logical one. This one has a z in it. And we got rid of the z right here. So then we're right here. Remember we put 0 in for the variable we just did. We just handled y's. So we'll put 0 in for y. Take negative x squared to the left side, and we get x squared is equal to 9. Drop the squared, put a plus or minus square root on the other side, and we get x is equal to plus or minus 3. Now that would make you think it goes from negative 3 to positive 3. And it would, except for the fact that they tell us it's in the first octant, which means that the x has to start at 0. And then it'll go to x is equal positive 3. And then this will be dz, dy, and dx. Well, we'll work with our inner one. That's our volume, by the way. I tend to forget to put that. X equals 0 to x equals 3. And then y is equal to 0 to y is equal to 9 minus x squared. There's an invisible 1 here, so the integral of 1 with respect to z is just z. From z is equal to 0 to z is equal to 9 minus x squared. dy dx. Which will be going from x is equal to 0 to x is equal to 3. Y is equal to 0 to y is equal to 9 minus x squared. Now normally I'd plug this in for z and plug this in for z, but when this is 0, we don't have to worry about that part. So this becomes, we're plugging 9 minus x squared in for the z. Actually, let me go ahead and put it. It doesn't hurt anything. Minus 0. Quit being so lazy. There we go. Well, ignoring the 0, that drops away. We're working with the next one. So this is going to be x is equal to 0 to x is equal to 3. Now, if you notice something here, 9 minus x squared. There's no y's in here, is there? This is like a constant. So remember, we put a if that's our constant portion, 9 minus x squared, then we just put a y beside it. From y is equal to 0 to y is equal to 9 minus x squared dx. So x is equal to 0 to x is equal to 3, and I'll put the 9 minus x squared in front of the bracket. And then we're going to have y left inside the bracket. And we'll plug these in. So plug in 9 minus x squared for the y, minus, and I'll put 0 in for the y, dx. Okay, so then we're going to have x is equal to 0 to x equals 3. The 0 drops away, so we got 9 minus x squared times 9 minus x squared. So that gives us 9 times 9 is 81. 9 times negative x squared is negative 9x squared. I'll learn to speak someday. Negative x squared times 9 is negative 9x squared. And negative x squared times negative x squared is positive x to the fourth dx. Which gives us x is equal to 0 to x is equal to 3 of 81. Negative 9x squared is negative 18x squared plus x to the fourth dx. And now we're going to integrate respect to x. So I'm going to have 81x minus 18 times, add 1 to our power, divide by our new power. So we've got 1/3 x to the third, plus add 1 to our power, divide by our new power. So 1/5 x to the fifth. But made a basic error there. X equals 0 to x equals 3. Now let me double check myself here. Okay, that looks right. Now we're ready to plug in our numbers. So let's see, 81 times 3 minus 18 times 1/3 is 6. And then I'll plug 3 in for the x, so I got 3 to the third plus 1/5 times 3 to the fifth minus, and I'll put parentheses as affect everything that follows it. I'll put 0 in for the x. So I got 81 times 0 minus, and 18 times 1/3 is 6. So that's 6 times 0 to the third plus 1/5 0 to the fifth. And these zeros all drop away, so I don't have to worry about that. This gives us 243 minus 27 times 6. Where's my calculator when I need it? Calculator. There it is. 27 times 6. I'm being lazy. That's 162. Plus 3 to the fifth. 3 caret 5. 243 over 5. 243 minus 162 plus 243 over 5. 243 minus 162 plus 243 over 5. Inner. And we get 648 over 5, assuming I typed it correctly into the calculator. And didn't make any basic math errors up above. Go ahead and save this. There we go. And let's look at our next problem. Use a triple integral to find a volume again. Okay. Z is equal to 3 minus y. Z is equal to 9 minus y squared. X is equal to 0. X is equal to 5. Y is equal to 0. And it's what's bounded by this. Well, if I were just to look at the Z and dy, like this. This z is equal to 9 minus y squared. Would look something. You put 0 in for y, we get 9, so it's up here. And then if I were to put 3 in for that, then it would go like this. It would actually go like that also. Now, the next one, 3 minus y. That's up a distance of 3. Let's say that's 3. And it would look something... would it pass through there? Let me think. 3, yeah, it would. It would look something like that. So that's what we're looking at there in terms of our y's and z's. That'll help you on the setup on that. Well, on the outer one here, it tells us directly that x equals 0 to 5. So that doesn't change. Now the y's. We've got y is equal to 0. Now, if I look at these two right here, z is equal to 3 minus y, and z is equal to 9 minus y squared. That's this part here. It's going to go from z is equal to 3 minus y to z is equal to 9 minus y squared. In terms of my z-axis, the z equals 3 minus y is lower, isn't it? So that goes there. Okay, now z's gone, and we're to this one right here. If z's gone, we put 0 in for it, so we get 0 is equal to 3 minus y, or 0 is equal to 9 minus y squared. Take the negative y over, we get y is equal to 3. Take the negative y squared over, and you get y squared is equal to 9. Or y is equal to plus or minus square root of 9. Y is equal to plus or minus 3. Now it seems like, well, there's two choices there. But if you think about it, when we're talking about intersections and so forth, then the logical choice is y is equal to 3 because it's in both of them. And then we're going to have our dz, dy, and dx. And yet again, I forgot to put my volume there. That's volume equals that. Okay, let's do the integral first. So do this one. So this is going to carry down x equals 0 to x equals 5. And this integral will carry down y is equal to 0 to y is equal to 3. We're integrating with respect to z, so we'll put a z there. From z is equal to 3 minus y to z is equal to 9 minus y squared. dy dx. Let's see, x equals 0 to x equals 5. Y is equal to 0 to y is equal to 3. Well, now we'll plug these values in. So I'm going to plug in 9 minus y squared for the y, or for the z. So we've got 9 minus y squared minus, and now put parentheses because that's changed the sign of everything follows it. And I'll plug in the 3 minus y for the z. dy dx. Okay, so that's going to go from x equals 0 to x equals 5. We can simplify this a little bit before I do the next one. Y is equal to 0 to y is equal to 3. Now I'm going to have negative y squared. This negative flips the sign of this negative y, so negative negative gives us a positive y. And the negative flips the sign of the 3, so that's a minus 3 and 9, which gives us 6. dy dx. Do the next integral. So we got x is equal to 0 to x is equal to 5. And integrate in respect to y, so this becomes negative 1/3 y to the third, add 1 to your power, divide by new power, plus 1/2 y squared, add 1 to your power, divide by new power, plus 6y, from y is equal to 0 to y is equal to 3. And then dx. Okay, so now we're ready to plug in those numbers. So we've got x is equal to 0 to x is equal to 5. Plug in the 3 for the y. So we've got negative 1/3 times 3 to the third plus 1/2 times 3 squared plus 6 times 3 minus, and do I got room to show it? Yeah, I guess I do. Negative 1/3, 0 to the third, plus 1/2, 0 squared, plus 6 times 0, dx. Well, all this drops away. These 0 to the third is 0, times 1/3 is 0, 0 squared is 0, times 1/2 is 0, 0 times 6 is 0, so that's all gone. And we got x equals 0 to x equals 5. 3 to the third is 27, divided by 3 is 9, so that's negative 9. 3 squared is 9, times 1/2 is 9 halves. 6 times 3 is 18. Which simplifies. X equals 0 to x equals 5. 18 minus 9 is 9, plus 9 halves, dx. This is actually a mixed number. 9 times 2 is 18, plus 9 is 27, so it's 27 halves. And I'll go ahead and move it out in front. X equals 0 to x equals 5 of dx. Well, now we're ready to take the integral with respect to x. So this gives us 27 halves x from x equals 0 to x equals 5. So we got 27 halves, and I'll plug 5 in for x, minus, and I'll plug 0 in for x. 5 minus 0 is 5. 5 times 27, 5, 3, 135. Let's see, 5, 3, yeah, 135. So my answer is 135 over 2. Assuming I didn't make any basic math, algebra, or basic calculus errors. We'll go ahead and save that. There we go. And let's take a look at our next problem. This one says, sketch a solid whose volume is given by the iterated integral and rewrite the integral using the indicated order of integration. Doesn't want us to solve it or anything, just wants us to rewrite it. So the outer one is the x, so we're going from x equals 0 to x equals 3. And then the next one is y, so y is equal to negative 2 to y is equal to 0. Next one is z. Z is equal to 0 to z is equal to y squared. dz, dy, and dx. Let's first write down, well, we have that here. Never mind. I'll wake up eventually. So we want, okay, x. So we want x equals something to x equals something. We want z. Z equals something to z equals something. This must be y. So y equals, oops. Y equals something to y equals something. And then we'll have dy, dz, and dx. Let's kind of sketch this first. First off, let's look at what in the world this looks like. Z is equal to y squared. This is our z-axis here, and this is our y-axis. Then it would look something like this. So it's got a parabola shape. Now all the rest are pretty straightforward. Use your imagination. I'm going to try to sketch this. Which probably means it'll look horrible. X is equal to 0 to x is equal to 3. This is our x-axis, so x is equal to 3. Y is equal to 0 to y is equal to negative 2. This is our y-axis, and this is, of course, our z-axis. Now, x equals 0 to x equals 3. So we're talking from there to here. The red indicates our this part. And then y. Y is equal to 0 to y is equal to negative 2. And here's negative 2, so it's going like that. And y is equal to 0 would be this right here. Oops. So that's our y. Now our z. We know it's got this kind of shape. And so if I were to come out down here to negative 2 on my y, I got way fast. If I were to go to negative 2 on my y, z would go up to 4. So negative 2 on my y, z on my 4 would be right there. And then if I would put y is equal 0 in there, it'd be right here. So it's going to be going like this. And then over on this side, look like that. And you really have to use your imagination here. Actually, I'll be able to see this side, wouldn't I? Okay, and then this line going out like that. That's not half bad. Not great, but it really does help to draw these so you can easily see. Now I'm switching the order of integration. This last one always has to be numbers. So it doesn't change. It's still going from x equals 0 to x equals 3. Now the y part here. Well, if I think of it in terms of the y values, this wall over here is the plane y is equal to negative 2. So that'd be negative 2. Now if I solve this, so I go z is equal to y squared. If I solve it for y, square root property, drop your square root off your y, put a plus or minus square root on the other side, and we get this. But if you look over where our graph is, y values are negative over here. So we want to keep the negative square root of z. So this is going to go from y equals negative 2 to y is equal to negative square root of z. And that would be this curved surface right here. Okay, now our z values. Obviously z starts at 0, looking at the graph. Question is how high it goes. Well, we already mentioned that if we put in the leftmost y value, which is negative 2, if we put negative 2 in for y up here, we get negative 2 squared, which gives us a positive 4. So this is going all the way up to z is equal to 4. Now the only part that has a curve to it is the y portion here. That's why you can put numbers on this. And I just want us to rewrite it. Now I didn't assign them in that particular book, in the lesson. But some of them want you to rewrite it all 6 ways, and I think that's kind of overkill. But from statistics, there's 3 possibilities you can put here. There's 2 here, then there'd be 1 here. So 3 times 2 times 1 means there is 6 ways we can set this up in order to solve the integration. Let me go ahead and save that. There we go. And time for that to blow up, so start a new one. There we go. Let me grab a drink and then we'll talk about these formulas. I'm not very big on physics. That's not my specialty. Not that I would call myself a specialist in math, but at least that's where I have better skills. But these are formulas, if you're going on to physics, that you could use to find different items. First one is a mass, so you can use that formula to find your mass. Now, the thing that looks like a P, that's rho. Usually, in the problems I've seen, they give you rho, what that's equal to. And then the m sub yz, that's the first moment about the yz plane. M sub xz is the first moment about the xz plane. M sub xy is the first moment about the xy plane. X bar is equal to m sub yz over m, little m. And y bar is equal to m sub xz over little m. And z bar is equal to m sub xy over little m. Now your center of your mass is given by the x bar, y bar, and z bar. So let's take a look at a problem dealing with this. Number 8. Okay. Looks like they're just wanting us to find one thing here, x bar. Find the mass and indicated coordinates. Rho. I don't do rho very well, so I just make it look like a P. That's equal to K. And then Q is, so this is what it's bounded by. So we got 3x plus 6y plus 2z equals 24. And x is equal to 0, y is equal to 0, and z is equal to 0. Now remember, we have to have bounds on items, because otherwise you got a three-dimensional shape that goes on forever. It's got an infinite shape to it. And this wants us to find x bar. But in order to find x bar, we need to find m sub yz, first moment about the yz plane, and we also need to find m, the mass. So first, let's find m. Okay, so first off, let's look at our z's. We're going to have 3x plus 6y plus 2z is equal to 24. And we want to solve for z. So take the 3x and 6y over to the right side. So we got 24 minus 3x minus 6y. And then we'll divide by 2. And you get z is equal to 12 minus 3/2 x minus 3y. So this beginning here is going from z is equal to 0 to z is equal to 12 minus 3/2 x minus 3y. And I don't know if I left enough room. Okay. Next thing we're going to do is y. So it's going to go from y is equal to 0, because it tells you y is equal to 0. Now going back to our initial equation, we got 3x plus 6y plus 2z is equal to 24. The variable we just did was the z's. So now they're not gone, so I'm putting 0 in for z. So we got 3x plus 6y plus 2 times 0 is equal to 24. So we've got 3x plus 6y is equal to 24, and we want to solve for y. So I take 3x over, we've got 24 minus 3x. Divide everything by 6. 24 divided by 6 is 4, minus 3 divided by 6 is a half. So y is equal to 4 minus 1/2 x. So y is equal to 4 minus 1/2 x. And then we'll have x is equal to 0, because this tells us starts at 0. And let me scroll down here. Now we're working with the x's. Go back to our equation. We got 3x plus 6y plus 2z is equal to 24. This time the y is now gone, and the 0 is gone. So we'll put zeros in for those. And we get 3x is equal to 24. Divide both sides by 3, and we get x is equal to 8. So this is going from x equals 0 to x is equal to 8. Now those are going to be the same bounds that we're going to have in all these, so that works out nice. In this problem, that is. Now we need rho. Well, rho they told us was k. And then this would be dz, dy, and dx. And okay, that's everything I need for the mass. So I'm going to take my k, put it out in front. And then I'll do the inner integral here. So that's going to be x is equal to 0 to x is equal to 8. And y is equal to 0 to y is equal to 4 minus 1/2 x. And when I take the k out in front, this just leaves me invisible 1 here. So integral of 1 is just z. Going from z is equal to 0 to z is equal to 12 minus 3/2 x minus 3y. dy dx. Okay, well, plug in those values. So we got x is equal to 0 to x is equal to 8. Y is equal to 0 to y is equal to 4 minus 1/2 x. Now we'll plug this 12 minus 3/2 x minus 3y in for z. So we got 12 minus 3/2 x minus 3y minus, and we'll put 0 in for z. dy dx. Okay. Well, now I'm going to work with this one. The 0 is, of course, going to drop away. Okay, so we got m is equal to k from x equals 0 to x equals 8. Then the integral with respect to y. That gives us 12y minus 3/2 xy minus 3/2 y squared. Y is equal to 0 to y is equal to 4 minus 1/2 x. Now again, we're integrating with respect to y, so the x and the numbers are all both treated the same as constants. So the 12 becomes 12y minus 3/2 x, we put a y on it, and then this y here we add 1 to our power divided by our new power. Okay, now we're going to plug these in for the y. And I'm only going to do part of it. Because if I put 0 in for y, I got 12 times 0, which is 0. I put 0 in for y here. You got 0 times x, which is 0, times 3/2, which is 0. If I put 0 here, 0 squared is 0, times 3/2 is 0. So that drops away. So we're going to have 12 times 4 minus 1/2 x. Again, we're plugging this in specifically for y. Doesn't change anything else. So minus 3/2 x times y, which was 4 minus 1/2 x, minus 3/2 times 4 minus 1/2 x squared dx. Now let me double check that. 4 minus 1/2 x minus 3/2 x, y minus 4, okay, minus 3/2, 4 minus, okay. And then we got x equals 0 to x equals 8. And 12 times 4 is 48. Minus 12 times 1/2 is 6, so minus 6x. Minus 3/2 times 4. 3 times 4 is 12. Divided by 2 is 6. So we got 6x. Negative times negative is positive, and that gives us 3/4 x. Okay, let me double check. 12, 6, negative 6x, 3/4. Okay. Minus 3/2. And square this, that gives us 16. 4 times negative 1/2 is negative 2, so that gives us negative 4x plus 1/4 x squared. Almost screwed that up. Let me double check myself then. Yeah. You can see why they just ask you to find one little piece of this, because these are not necessarily, they're not horrible, but they're kind of long, so easy to make a mistake too. So I got 48, negative 6x is negative 12x plus 3/4 x minus 3/2 times 16 is 48 over 2, which is 24. 48 over 2, 24, yeah. Negative times negative is positive. 3 times 4 is 12, divided by 2 is 6, so that's plus 6x. 12/2, yeah. Minus 3/8 x squared. dx. Let me double check that. 12 divided to 6. Okay, minus 3/8. Yeah, that looks good. Okay, x is equal to 0 to x is equal to 8. We got 48 minus 24 is 24. That's gone. That's gone. Negative 12x plus 6x is negative 6x plus 3/4 x minus 3/8 x squared dx. Okay. Now this is a mixed number. We can take negative 6 times 20 times 4, that's negative 24, plus 3 is negative 21, so minus 21/4 x. Negative 24, negative 21x, minus 3/8 x squared dx. And I'm out of room, so let me write this down, and then we'll continue on the next page. Okay, from x equals 0 to x equals 8. 24 minus, and it'd be a miracle if I don't make a mistake somewhere in this problem, but we'll see. Dx. And let me write this down up above here. Okay. 0 to x equals 8. Y is equal to 0 to y is equal to 4 minus 1/2 x squared. Z is equal to 12 minus 3/2 x minus 3y. Okay. So let me save this. And what problem is this? This is problem number 8 continued. So 8 continued. And we got m is equal to k from x equals 0. X is equal to 8 of 24 minus 21 over 4. X plus minus, boy, that would have been a bad mistake, minus 3/8 x squared dx. Okay. K stays out in front. Integrate respect to x. So we got 24x minus 21/4 times 1/2 x squared minus 3/8 times 1/3 x to the third from x equals 0 to x equals 8 dx. Well, to begin with, the 0 I don't need to plug in. 24 times 0 is 0. 0 squared is 0 times 1/2 is 0 times 21/4 is 0. 0 to the third is 0 times 1/3 is 0 times 3/8 is 0. So that all drops away. So the 8 is the only thing we have to plug in. So we got 24 times 8 minus 21 times 1 is 21. 4 times 2 is 8 times 8 squared minus, those 3's would cancel, and I got 1/8 times 8 to the third. That seems too nice for the way everything's working out, considering I made the numbers up. Well, I guess it is. Let's see, what is that? 192? 2, 3, 16, 9. 192. This 8 squared is 64, divided by 8 is 8, so minus 8 times 21, 168. Minus, that 8 cancels one of these 8s, and that's leaves us 64. Just double checking myself. Don't trust my basic math. And I'm not even going to try to do that in my head. I mean, it's pretty simple, but I'll still screw it up. 182 minus 168 minus 64. And that's not good. I came up with a negative. Of course, we don't know what k is, but that still doesn't seem right. Okay, let me double check myself. Oh, I'm going to hate it if I screwed up somewhere. 3x plus 6y plus 2z is equal to 24. X equals 0, y equals 0. Okay, solving for z. Take that over, divide by 2. 12 minus 3 halves minus... Okay, so 12 minus 3 halves x minus 3y. Y's. Put 0 in for z. Solve for y, so take that over. Divide by 4. Okay, that looks good. And then the x's. X equal 8. Okay, that checks. Okay, the integral of that is z. I plug this in, I get 12 minus 3 halves x minus 3y minus 0. That looks good. Which gives me 12y minus 3 halves xy minus 3 halves y squared. So far, so good. 0, I don't need to worry about plugging in. I plug this in. 12 times 4 minus 1 half x minus 3 halves x times y, 4 minus 1 half x minus 3 halves, that's squared. Looks good. 12 times 4 is 48. 12 times that is negative 6x minus 12 divided by 2 is 6x plus 3/4 x squared. That should be an x squared. Man. Unfortunately, it won't be right on this, I don't think. What if I can annotate it? Well, there's a lot of options there. Boy, that just stinks. 3/4 x squared, 3/4 x squared, 3/4 x squared. You know, I about got it correct down to the bottom here. So let me continue this line here. So let me write that down. So it should be m is equal to k, x equals 0, curse, 24 minus 6x plus 3/4 x squared minus 3/8 x squared dx. I could have got by with it if I'd come up with a positive number, but to come up with a negative number. So as you look at this, you can scratch out this last line here. This is not valid. Okay. Doing so well, or at least I thought I was doing so well. I hadn't caught my errors if I had made any. Darn these physics problems. You can get by with error in normal math because you don't know whether you should come up with positive or negatives. Okay, so this should be k, x equals 0 to x equals 8, 24 minus 6x plus 3/4 x squared minus 3/8 x squared dx. Okay, try 2. X equals 0 to x equals 8. 24 minus 6x. Now, get a common denominator. This would be 6/8 x squared, so that gives us 3/8 x squared dx. Okay, so now I'm going to take the integral of that. So that gives us 24x minus 6/2 x squared plus 3/8 times 1/3 x to the third from x equals 0 to x equals 8. Makes me wonder how many errors I actually have spread throughout these documents. 0 again will drop away. That doesn't change. We'll plug 8 in. So I got 24 times 8 minus 6 divided by 2 is 3 times 8 squared. Those 3's cancel, and I got 1/8 times 8 to the third. So that gives us, let's see, 2, 3, 192. Of course, my confidence is shot now. Minus 3 times 64, what was that? 3 times 64, 192. This 8 cancels one of those, so that gives me 8 squared, so plus 64. So we get m is equal to 64k. Now let me write that down, because I know I won't finish this on this page. We'll have to continue it. Okay. So we just found m. Well, we want to find x bar, so we want to find our first moment about the yz plane. So we're going to find this. And our formula, let's see, I got these written down here. X equals 0 to x equals 8. Y is equal to 0 to y is equal to 4 minus 1/2 x. And z is equal to 0 to z is equal to 12 minus 3/2 x minus 3y. MYZ will have x and then rho. What was rho? Rho was k. Then we'll have dz, dy, and dx. Okay. Well, the k I can put clear out in front, so I don't need to worry about it. So we got x is equal to 0 to x is equal to 8. Y is equal to 0 to y is equal to 4 minus 1/2 x. And we'll integrate with respect to z. The k's gone, so the x would just become xz. From z is equal to 12 minus 3/2 x minus 3y, or z is equal to 0 to that. dy dx. Okay, so we'll plug that in for z. And if I put 0 in for z, it just drops away, so I don't need to worry about the 0 part. I doubt if we'll have to worry about the z part or the 0 part in any of these, to be honest. X equals 0 to x equals 8. Y is equal to 0 to y is equal to 4 minus 1/2 x. And we're plugging this in for z. So we're going to have x times z, which was 12 minus 3/2 x minus 3y. dy dx. Okay. Do a little bit of simplifying. So x times 12 is 12x. X times negative 3/2 x is negative 3/2 x squared minus 3xy. Multiply the x through. dy dx. Well, now let's integrate respect to y. So that gives us 12xy minus 3/2 x squared y minus 3/2 xy squared. Again, we're treating the x like a constant and numbers like constants, and we're just working with the y's. From y is equal to 0 to y is equal to 4 minus 1/2 x. Now again, it doesn't do me good to plug in y equals 0 because all of it drops away. So that gives us x equals 0 to x equals 8. We'll plug this in for y. So we're going to have 12x times 4 minus 1/2 x minus 3/2 x squared times 4 minus 1/2 x minus 3/2 x times 4 minus 1/2 x squared dx. So what is this? M sub yz is equal to k, then from x equals 0 to x equals 8 of 12x 4 minus 1/2 x minus 3/2 x squared times 4 minus 1/2 x minus 3/2 x times 4 minus 1/2 x squared. Assuming I didn't make a math error up above, algebra. or calculus. So let me save this. And we'll go to page 3 on this problem. And believe it or not, this is a simple problem. Okay. So, continuing this, remember that MYZ is equal to K, X is equal to 0 to X is equal to 8 of 12x times 4 minus 1/2 x minus 3/2 x squared, 4 minus 1/2 x minus 3/2 x times 4 minus 1/2 x squared dx. I think I got an extra parentheses in there, but assuming I wrote it down right, let me double check everything. That parentheses shouldn't be there. So we got x is equal to 0 to x is equal to 8. 12x times 4 is 48x. 12x times negative 1/2 x gives us negative 6x squared. Minus 3/2 times 4 is 12 over 2, which is 6. So 6x squared. Negative times negative is positive. 3/2 times 1/2 is 3/4. X to the third. 3/4 x to the third. Yeah, okay. And that gives us minus 6x. Negative times negative is positive. 3/4 x. Oh, what am I doing? Oh, man. Scratch, scratch, scratch. Losing my mind. If I screw up this one, I'm not going back and looking for it. Let's call it good. Leave it for the physics majors. Okay, I square this. 4 squared is 16. 4 times negative 1/2 x is negative 2x, and that gives us negative 4x because there's 2 of them, plus 1/4 x squared dx. Okay, let me check that. 16 minus 4x plus 1/4 x squared. Okay. X equals 0 to x is equal to 8. And then I got 48x minus 12x squared plus 3/4 x to the third. Negative 3/2 times 16 gives us negative 48 over 2, negative 24x. Negative times the negative is positive 6x squared. Gee, I was going to do it again. Minus 3/8 x to the third dx. Minus 48 over 2 to minus 24. That's 12 over 2, 6x squared minus 3/8 x to the third. Okay, so x to the thirds. Here's an x to the third, here's an x to the third. That'd be 6/8. 6/8 minus 3/8 is 3/8 x to the third. X squared, x squared. Negative 12 plus 6 is negative 6x squared. 48x minus 24x is 24x. And no numbers. Yeah, I guess that makes sense. dx. Okay. K stays out in front. Integrate that. That gives us 3/8 times 1/4 x to the fourth minus 6/3 x to the third plus 24 over 2 x squared from x equals 0 to x equals 8, which gives us 3 over 32 x to the fourth minus 2 x to the third plus 12 x squared from x equals 0 to x equals 8. Now again, it doesn't do us any good to plug 0 in for x, so that disappears. And we got 3 over 32 times 8 to the 4th minus 2 times 8 to the 3rd plus 12 times 8 squared equals, let me be real lazy here, 3 divided by 32 times 8 to the 4th minus 2 times 8 to the 3rd plus 12 times 8 squared. 332 times 8 to the 4th minus 2 times 8 to the 3rd plus 12 times 8 squared. Enter. Math. Enter. Oh, it's 128. So 128k. That's MYZ. Oh. Okay, what we're looking for then is x bar. So from our formula, x bar is equal to MYZ over little m. That's this one right here. Which is going to equal to 128 over k over 64 over k. K's cancel. 128 divided by 64 gives us 2. So that'd be what they're asking for. And the end of that problem. 3 pages later. Okay. Let's look at our next problem. These are moments of inertia. And I think these are a lot easier. We're just doing setups. These just get so nasty that you can see this, the very simplest one I chose took forever. So the moments of inertia about the x-axis is equal to the integral of y squared plus z squared times rho. The moment of inertia about the y-axis is equal to the triple integral of x squared plus z squared times rho. And you notice it's pretty easy to remember. We're finding the moment of inertia about the y-axis, and we have an x squared and z squared. Moment of inertia about the z-axis, we have an x squared plus y squared. Now we're going to do the setups on these. We're not going to actually go through and find values of these. The book talks about doing it with technology, but I really don't have technology to do that. I've got T83, T84, but that won't cut it. Okay, so this one. Q is equal to the order triple such that x is between -2 and 2, y is between -3 and 3, and z is between 0 and 0 and 3 minus x. Okay, and rho is equal to the square root of x squared plus y squared minus z squared. And it says set up the triple integral gives the moments of inertia. Set up triple integrals. I changed the instructions slightly in the book. The book just says find one. But since we're doing a setup, I thought, well, who cares then? That's easy. So the moment of inertia about the x-axis, we need our setup here. So this will be x equals -2, x is equal to 2. Y will be y is equal to -3 to y is equal to 3. And z will go from z is equal to 0 to z is equal to 3 minus x. And then we need y squared plus z squared. So we got y squared plus z squared. And then rho, that's my next one, rho, which will be the square root of x squared plus y squared minus z squared, dz, dy, dx. Now our moment of inertia about the y-axis. These boundaries are the same. X equals 2 to x equals 2, or x equals -2 to x equals 2. Y is equal to -3 to y is equal to 3. Z is equal to 0 to z is equal to 3 minus x. And we'll have x squared plus z squared here, times rho, which is square root of x squared plus y squared minus z squared, dz, dy, and dx. And let's find our last one. Again, this is going to go from x equals -2 to x equals 2. And this will go from y is equal to -3 to y is equal to +3. And z is going to go from 0 to z is equal to 3 minus x of y, try it again, x squared plus y squared times rho, which is square root of x squared plus y squared minus z squared, dz, dy, dx. And those would be our answers. So let me go ahead and save that. And bring up another tablet. And let's look at our last problem. Yeah, last problem. Let me grab a drink first. Solid bounded by z is equal to 9 minus x squared minus y squared. Z is equal to 0. And rho, our density function, is equal to kz. And it says, using the description of the solid region, set up the integral for the mass, the center of the mass, and the moment of inertia about the z-axis. Oh, stand for a second here. I've been sitting too long. Center of mass. I don't know if I want to do that or not. Let's think about that one. Okay. Now for our mass, it's going to equal to our x values, our y values, and our z values. Probably leaves me enough room. I think I won't set up that. I'll just set up the integral for find all the moments. I won't actually find them. Okay. Now for our z's. Starts at z is equal to 0, tells you that. And then goes to z is equal to that. So 9 minus x squared minus y squared. Now remember to find our y's. We start with that equation. Z is equal to 9 minus x squared minus y squared. And if I'm working on this integral, this one's gone. So z is equal to 0. 9 minus x squared minus y squared. Take that over, and we get y squared is equal to 9 minus x squared. Drop the squared, put a plus or minus square root around the other side, and we get that. Now, density function bounded by this, and z is equal to 0. Okay, so z can't be negative, but it doesn't put any stipulation on x and y. Which means that this will go from y is equal to negative square root of 9 minus x squared to y is equal to positive square root of 9 minus x squared. Okay, now let's look at our x's. We'll start with z is equal to 9 minus x squared minus y squared. The z's are gone, the y's are gone, so we'll put 0 in for z, we'll put 0 in for y. Take negative x squared over the left side, and we get x squared is equal to 9, or x is equal to plus or minus 3. So this is going to go from x equals negative 3 to x is equal to positive 3. And then rho is kz, dz, dy, dx. Well, to find the center of mass, you need all of these. So I'm just going to do this setup on these. So moment, first moment about the YZ plane. These are going to be x equals -3, x is equal to 3, y is equal to negative square root of 9 minus x squared, y is equal to square root of 9 minus x squared, z is equal to 0 to z is equal to 9 minus x squared minus y squared. And then we'll have our x. I was thinking it was. We have our x times rho. It's a missing variable. See how we have y and z here? So this will be x times rho, which rho was kz. dz, dy, dx. Our next one is a moment about the xz plane. So m sub xz. So that'll be x is equal to -3 to x equals 3. Y is equal to negative square root of 9 minus x squared to y is equal to positive square root of 9 minus x squared. Z is equal to 0. Z is equal to 9 minus x squared minus y squared. Our missing variable, xz, so we got y times rho. dz, dy, dx. Okay, now a moment about the xy. So that's going to be x is equal to -3 to x is equal to positive 3. Y is equal to negative square root of 9 minus x squared to y is equal to positive square root of 9 minus x squared. Z is equal to 0. Z is equal to 9 minus x squared minus y squared. Missing variable, xy, z, times rho, which was kz, dz, dy, dx. Now, that was the find a mass to do the setup. The second one was the center of the mass. Well, center of mass then would just be to plug them into these formulas. And then that would give you your center of your mass. I'm not going to actually do that part. I think that part, assuming we had the integrals set up, would be pretty easy. Moments of inertia. Let's go ahead and do those. Excuse me. Moment of inertia about the x-axis. Now I'm not gonna write this down each time. It's the same. These are the same as up here. And then we're going to have y squared plus z squared times rho, which was kz, dz, dy, dx. And again, that's the same as up above. About the y, it'll be the missing variables, which is x squared plus z squared, times rho, which is kz, and then dz, dy, and dx. And then regards to z, we'll have the same setup. All that still stays the same. And then we'll have x squared plus y squared times rho, which is kz, then dz, dy, and dx. And those are our setups for those. Lazily done. I'm getting tired, man. Let me go ahead and save that. Working on this video forever, I think. There we go. 12. And that was the last one, so let me go ahead and save this.